In this question, we're going to make month-end payments of $250 into a retirement account for 30 years. And at the end of each year, we're going to actually contribute an additional $2,500. We want to determine how much is going to be in the account after 30 years, assuming that the account can earn 6% interest compounded semi-annually. To solve this question, I'm going to design a little chart that we can use so that we have all the numbers that we need to use our calculator. We're going to break this up into two columns. We're going to deal with the $250 payment stream as separate from the $2,500 payment stream. For the payments of $250, let's take them as negative $250 since we're going to put them into our savings account. These payments happen at the end of every month. So our frequency number here should be 12. For these payments, they should be earning 6% interest compounded semi-annually. We're going to assume that our account starts with a zero balance, and we're going to be asking our calculator for the future value. So the last thing we need is a value for n. We are going to be making month-end payments for 30 years. 12 times 30 implies we should be making 360 of these payments. Next, let's start filling in information about our payments of $2,500. Again, we're going to be asking for the future value of our account, understanding that we've started with a balance of $0. Our interest rate is still the same at 6% compounded semi-annually. However, the payment structure is a little bit different. We actually only have one payment at the end of every year. One payment for 30 years implies that we're only going to have 30 of these equal-sized payments over the course of our term. Moving over to our calculator, let's begin with the 250 column first. So I'm going to start with n is equal to 360. Let's get our interest rate of 6% in, and then go into our submenu. My PY is already 12. And scrolling down, I just need to update my CY to be 2. I'm going to exit out of that submenu. Let's take 0 as our PV, 250 negative as our payment size, and we're going to ask the calculator to compute our future value. And I get $247,619 and about 84 cents. So let's go back and update some of the information for our second column, which deals with the payments of $2,500. Here we need to update n to be equal to 30. Our interest rate stays the same. However, we do need to go into the submenu. In this case, PY needs to be updated to 1, and then I'm going to scroll down and just make sure that CY gets back to 2. Let's go ahead and quit that submenu. PV is still 0. I need to update my payment sizes to 2,500, and then we can go ahead and compute the future value. Here I get $200,804 and about 73 cents. So in order to get to our final answer, we need to add up this future value with the future value we have in our first column. So let's take our 247,619.84 and we'll add it to what we have in our calculator. And that should give us a future value of around $448,424.57.